Hello. Today we're getting very close to actually drawing a keyboard on the screen and showing the user what they can type, which is going to be pretty satisfying to see. And in any case, what we're going to do is we're going to first do one task which I think needs to be done before we work on the keyboard drawing itself, and that is to have the make map functionality actually sort the codes. So right now, if we look at the right-hand side of the screen, these codes are not sorted by their ASCII value. So that means that it's going to be hard to find the codes when it's going to be hard to find the codes when the keyboard is like trying to figure out what the user is able to type. And so in that case, we're going to we're going to actually have this sort the keys, and what MakeMap will do is it's going to use stir CMP function to look for the first key that's been pressed. So let's say the user started pressing 2. Well, it's going to look for 2, and it's going to and it might find something in the middle of 2, the like codes that start with 2, and then it's just going to have to go backwards until it finds the start of the code sequence. Or perhaps it can go backwards while filling in the codes and go forwards while filling in the codes, and so it doesn't have to it doesn't have to do anything kind of well, it doesn't do this like moving backwards in the array without doing anything, which is a little bit unelegant. Anyway, that's a bit of a brainstorm. In any case, we're going to have make map sort the codes, and I don't know if we need a functionality to not sort the codes. The thing is, the way this is written now, the codes are very easy to read, but they're not easy for the software to look at them, to like try and search in this array, because we can't use stir CMP. We have to use a kind of custom function. And even if we say, okay, let's use like a custom like comparison function to do the search in this array, I don't know if it's going to work perfectly, because it may not really work all that well, because there's like you have uh, you have these characters which are shift characters, and so like 7 is shift. If you do shift 7, it's ampersand, and ampersand is now where is that? Where's the ampersand code? Uh, oh, I don't see. Oh, the ampersand code is hard coded, so it's all the way up here. So, right, the hard coded ones are not sorted at all right here, and so we're gonna have to do something to sort them, because this is not good. And I suppose what we're gonna want to do is sort them first by length, because there's no real the keyboard drawing code is going to want to first like show it's only going to show codes that have a certain length. And so when the keyboard is first on the screen, it's going to show codes of length 1, and so we need to be able to just loop through the first couple of items and show length 1 code. And as an example, like in this this like keyboard viewing thing in this other input system I wrote, we have we like don't oh, this doesn't actually show the initial. So for instance, I can press just capital A, and it'll enter this character that you see I'm typing. And in this input system we're creating now, I'm going to want to show this character right here, just as a kind of hint that, hey, you can enter that character without pressing any other characters. And so that means that we want to put the 1 character codes first, and we'll probably want to put the 2 character codes next, and then the 3 character codes after that. Right now we don't create 3 character codes, but that's fine. But later, when when we have more like characters to type, when we're supporting more than 1250 kanji, we're going to like we're going to have the keyboard look and find the 3 character long codes and not have that interspersed with 2 character codes while it's trying to populate the keyboard. And so this and also there's going to be for like there's going to be a lot more 3 character codes than 2 character codes, and I wonder if the opposite is true. Like I don't want to have 3 character codes interspersed with 2 character codes. Yeah, maybe this isn't quite true. For two for 1 character codes, we do want to have be able to sort to loop through them, and so we're going to put them first. But for 2 character codes and 3 character codes, I don't think it's actually that important to sort by length. Uh, but we'll do it anyway. And anyway, so we have a let's go to makemap.c, and this is the makemap function, and it's going to get the romaji codes and kanji codes. And now we're going to say we're going to sort, right? We're going to do a qsort, and the first argument is nothing. Let's open util.h and look at qsort. So first we give it the name of the element we want to assign, and L. What is L? Oh, L is the array itself. So we're going to sort the codes dot key mapping array is going to have what does key mapping array look like? Edit make map.h. That's the type we're editing. Make map. What was it? Make. It's not make map.h. Because make map.h is the command. So this is another problem. We need to have we need to actually make this into reusable logic that we can invoke without having it be a user interface like command. Um, so yeah, that's a bit. We have to decide on a name. That means. Anyway, we can add the qsort logic now, and handle the like commandification later. So we'll have a sort function, static int code less than, and this is the comparison function, and we're going to say, let's see, where is make map dot? Okay, we want to go to make map.c, I guess, and the it's in kanji distribution, I guess, kanji distribution.h, and we have no, it's not here. It is key mapping array. Where's key mapping array? Edit romaji.h. Key mapping array. Okay, it's here. That's a little surprising. We probably want to refactor that eventually. So anyway, we have romaji.h already included, and we have so we have key mapping. So struct key mapping const a, and let's do that again. Okay, now key mapping orig. Now this is a null terminated. This is a null terminated string, isn't it? So is that right? It's null terminated. Yeah, because none of the characters are more than that long. And conv is also null terminated because we're doing 3 bytes for each. A con of characters could be 3 bytes long, and we have 1 byte for the null terminator. So 2 times 3 plus 1. That's the plus 1 is a null terminator. So we got to do size t alien equals a dash sterling a dash l no orig All right, and size t b lang equals strlang b dash orig. Let me see if I'm using the right type here. Size t, yes. Strlang returns size t. So if a lang is not equal to b lang, then return a lang is less than b lang. And next, we have, otherwise you want to say return stir cmp of a dash orig and b dash orig is less than 0. That will tell if it's less than. All right. Now we do codes.l is the array, and the comparator is going to be let's see, code. What was it? Code less than. So actually, I guess we don't want to pass the key mapping. I wonder. Yeah, we don't want to pass the key mapping. We want to pass the string. So let's fix that. Yeah, and char const, and then char const. Okay. All right, code less than. So now we do code less than, and we have to use A and B, I believe. A and B. Yes, we're setting A to indexes. Oh, A and B are indexes, not the actual pointer to the value. Orig and codes b dot orig. Okay, and then what are the other arguments? Count and the less than. Oh, we never passed the count function. Okay, or the count value. So then we do codes dot count. Right. Now let's make new sort and try this again. Sort codes. Okay. There. Okay, try again. New sort make map. Okay, good. It's putting one character codes first, and that's what we want. And it looks like everything else has the numbers first, and then it's alphabetical. That's good. And so we could say, like, for the last character, you actually sort it by the key index, but I don't know if that's going to be all that helpful. Essentially, when we're looping through the codes that have a certain prefix to draw them on the keyboard, we are going to have to convert this last character to the key index and do that just for each character, and that will be a little bit slower, but I'm pretty sure it's not going to matter. And I think that sorting these by key index is gonna make things a little more like messy anyway. The comparison function is going to be a little more messy anyway. But maybe we do want to sort by the key index after all. Then we can sort all the characters by the key index, and then that means that we can. Oh, but the thing is that the keys may not be contiguous anyway. So if we skip a key index, that means when we're looping through, we're not going to be able to figure out what the right key index is without actually converting it. So we're still going to have to convert it, in other words, in case there's a sparse mapping. So yeah, there's no benefit of sorting by key index that I can think of, except for maybe it might be easier for manual verification or something like that. All right. All right. So now let's look at the diff, and this looks fine. This is a very simple simple change in and of itself. So I'll do make, and we'll do this to update the test. Make again. All right. Now diff. Okay. And this really is, I don't think it's worth verifying. I mean, I don't think there's any room for mistakes here in what in the code I just wrote, considering the fact that I already looked at the output of the command, and there didn't seem to be any issues. But let's look at the stats, maybe make sure that the number of changed lines are the same. So get diff stats, I think it is, and we'll just do make sure that we're not adding more lines than we're removing or something like that. Diff stats. Get help diff, something like stats or stat dash dash stat. I guess it's just dash dash stat. Delete to s, and okay. So the number of insertions equals the number of deletions. So that's fine. Now I think that we can commit this. So we're going to say we're going to call it the placeholder commit message, which I'll rewrite later, is sort keys so the keyboard drawer can find them easily. More like sort codes. Sort codes can find them easily. Okay. Next, I think we want to move this out. So we have ergonomic sort. I'm just trying to think about what like, because now we want to move this function, move this logic here, which is only like 4 lines of actual code. We want to, oh, we also want to move this. We want to move that all to a separate module, and I guess we'll call the new module mapping. Okay, so let's call it, let's see, we're gonna make a new module, and we'll base it off of rank coverage, I guess. All right, well, all you have to do is add the source file in this line, and so make map dot, or no, mapping dot c. And let's fix the lines on here. I'm gonna make this use nice line wrapping. All right. Okay. Now let's save that, and headers. We're gonna have to add a header, mapping.h. And oh, looks like some stuff is missing from headers. So, let's look. ls star or l star.h. Okay, command.h, kanji-db.h, and do kanji distribution.h. Rank coverage.h is already there. Domaji.h is there. Test util is part of the test, so we don't need that. And util.h. Okay. Now let's make sure that let's sort this alphabetically. Util. Okay. Util should go at the end. To R. And then rank coverage mapping should go here. No, it should go earlier than that. All right. And that looks correct. Okay. Good. Now, let's create the make mapping files. let's see here, and I will go to new source, and let's see. I'm going to open mapping.h, and here we have makemap.c, which is going to have to move some stuff out of it. Actually, it's going to have to move a lot of stuff out of it. Basically, we're going to move everything except for most of this function, the makemap command function. All right, key mapping array is initialized to that. So I'm thinking about the interface we want. It's probably going to be something like void mapping or populate, mapping generate. See, this is unfortunate because the command is basically the same thing I want to name this new function. So it's more like generate or populate map. Populate mapping, I guess. Or I'll prefix it with the module name. Mapping populate. Okay. And struct key mapping array codes and int ergonomic sort. All right. Simple enough. And what else goes in the header file? This this thing will have to go in the header file. Oh, do we need less than, maybe we need like we actually need a comparison because we're gonna have to do a binary search later. Well, we don't have to actually move the less than thingy yet. We can just make that still have that be a private thing, and that's fine now. So we will go ahead and do include omaji.h for the key mapping array. And now we're going to have to just move a whole lot of stuff into mapping.c. And maybe we can start by just putting the entire file there. Okay, we don't need commands. We do need our own module, pound include mapping.h. Okay, and ergonomic sort is a argument that we pass now. So mapping, so void mapping generate and struct key mapping array codes, and it is ergonomic sort. Now I wonder, do we want to actually make this part of the code structure, have this be passed along with the code structure? So in other words, we're going to make a new structure which contains all of this stuff. Where do we use key mapping array? That just seems like a strange place to put in romaji.h. Key mapping. Make map in romaji.c. We do use it in C. So we do use it in romaji itself. So maybe that's good enough for now. So in that case, I don't want it to be part of key mapping array. I want to create a new struct outside of it. So mapping.h. Let's do a struct key. Let's do struct mapping, I guess. And we'll have a struct key mapping array codes and int unsigned ergonomic sort. So the fact that it's signed, it's unsigned rather than int. If it were int, then that would mean that this is that one's complement bit. So this means that int, the only values this could have is 0 and -1, which is just kind of unintuitive and maybe surprising if you end up using it in some kind of a math context. So just to avoid surprising people with -1, we use unsigned rather than int. All right, mapping populate and void mapping destroy, because now we have we now have this thing struct. We now have an array that we have to get rid of. So struct mapping. Okay. Now, I don't know. Do we want to just make that a mapping? Destroy mapping. Because this is kind of, I don't really like the fact that I have to pass a pointer to a pointer. I do want to null. Oh, I don't need to nullify the thing after it's. Never mind. I was thinking I want to set the pointer to null after it's passed, but I actually don't, because the user may be allocating this on the stack rather than the heap. So we do just need the pointer, and we'll just set it, do memset 0 and destroy in here. Okay, now edit mapping.c. Mapping.c. Yeah, now I wonder. So let's write mapping.c first, and ergonomic sort is no longer going to be here. Is alt hands we still need? Column value ergonomic less than ergonomic sort. So if get kanji codes m. Okay. Mapping dash codes.l. So this is going to change a little bit. Get kanji codes. Int, do we want to just pass it separately? Ergonomic sort? I guess kind of. I don't want to have to refer to it differently. I'm feeling kind of lazy about that. Anyway, so yes, now what do we do? So we want to, we have codes. Oh, let's add mapping destroy here. Let's write this first. Struct mapping. And so we can do destroy array mapping dash codes dot l, and then memset mapping 0 size of mapping. So this is kind of redundant because this one is already zeroing out the thing, but that's fine. I don't think I care that much. So it's re-zeroing out stuff. Big deal. And I guess once it gets really deep, the runtime complexity could get bad. But that's fine. If like the struct gets even more nested, I guess that may be a problem. Now, okay. So we're going to do get no magic codes. Get no magic codes. Mapping generate. Oh, mapping populate. Mapping populate, and we have a struct mapping. Mapping populate. Okay. Let's see. Mapping populate. Now we got to do the struct mapping. Now mapping dash codes. Dash codes, and we also do mapping dash ergonomic sort, and then we need to sort it, and then this function is done. That's fine, and we don't need this anymore. We can get rid of this. Now we do need these other includes. Let's keep those. Now we can fix makemap.c. No longer is going to be this complicated. So this just needs, now at this point, this needs mapping.h and commands.h. Probably nothing else. Or, yeah, I think it doesn't really need anything else. All right, make map. Okay, so struct mapping equals there. And then mapping dot ergonomic sort. Then, okay. Then we do mapping populate. Mapping. Right. And then we do a loop over, oops. Okay. So I'm wondering, does nomaji.c does not need the ergonomic sort bit. So that's why we're using a separate structure here. Okay. I mean we're nesting it rather than just putting everything in the key mapping array struct. Mapping. So mapping.codes.count and mapping. All right. Then destroy mapping destroy. Okay. Good. But here we're not cleaning up properly. So mapping is set here, but we're not destroying it. So we do kind of have to, even though we know ourselves that we just, since we just wrote it, that we're not actually allocating anything until we call mapping populate, we do create mapping here and then start using it here. And so I think it would be a little bit more like self-evidently correct if we did a go to here and then cleaned up. So int res equals 0. Now we do res equals 3 and go to clean up. All right, clean up. Return res. All right. Okay. It's looking good. Now, just double checking this function to make sure we include everything that we need, and I think we do. And then mapping.c itself. Okay, I don't, let me build and see, let the compiler tell me what I forgot. Util, oh, we need util.h. Make. Codes.l, mapping.c. So 161, go to here. Now, this reminds me, I do want to fix the make files so it's like is more modular and it doesn't try and rebuild files that it's already built before. And I think that maybe right now it does. Yeah, it is like, let's see, in Makefile, we have a bit of a like problem in Makefile. Makefile here. So shared sources is used in sources and test sources. So if we look for sources, we see that it's being built, it's being used here to build, and it's being used to build some tests. And this is bad because it's going to go ahead and try and build a test. Excuse me, even though new sort is not built yet. Now, one way to fix this is to just make new sort a dependency on the test. But that's kind of a lie. It's not really true that they depend on the binary itself. The tests are a separate binary. So I think I eventually want to clean this up so that it only builds these sources once. But I need to kind of read up on how Makefiles work later, like offline, when in order to know exactly what I need to do there. Codes.l. Okay. Mapping. Bing. Okay. Make. util.h in mapping.c 167. Destroy array. Codes.l dash array. Destroy array. Oh, we don't need .l there. So see, I just fixed one error, and the thing is that one error was causing a huge amount of output, and that's just no fun to have to deal with. Okay, so this I think is done. I'm gonna just go over this really quick and make sure that I'm not duplicating any stuff. Because let's see, make map.c is basically, this is basically what we need. So in mapping.c, which is the generic shareable code, this is fine. All right. So now we want to commit this, and we'll just say this is move map generation logic to shareable module. All right. Next. Next, we need to. Next, I think that. Let's see. We want to do the keyboard drawing logic, right? And that means that eventually the keyboard is going to have to do a binary search in the mapping array. And that means that eventually this is going to have to be a shared, like something that's shared and available to others. But we don't need to do that right now. Let's just wait. That's going to be a tiny change. And I'm making a big deal out of it now unnecessarily. So we can actually start working on the keyboard, the keyboard thing, I suppose. So what is keyboard.h going to look like? Keyboard.h is going to say we're going to do void keyboard draw, right? And we're going to say take a let's do struct mapping, and what we can do is we can just now eventually we're going to have to do like char const code prefix, so that will take what the user has typed already. But let's not do that now, because drawing the keyboard itself is going to be kind of complex anyway, so I don't want to sign up for more than I really am ready for. So mapping.h needs that. Okay. Now we're adding a keyboard header, keyboard.h. And let's see. Okay, now we can do, let's get rid of this. We don't need that. And let's get rid of one of these. Keyboard. Oh, we do need to edit the Makefile again. We need to add keyboard.c. Make map. Oh, I forgot to alphabetize the shared sources list. Unfortunately, keyboard.c. Okay. Let's handle that. Let's handle the alphabetizing of that. I'm going to let's add this incomplete keyboard module. All right, now we're going to go to let's just make a new commit, and then we'll do an interactive rebase to edit the order of commits here. So we have I'm going to do a kind of a quick sort here. Romaji util last string contained. Okay, last string contained goes here. and check kanji database order is here. And I wonder, do we just want to like maybe just put everything on a separate line? That just seems easier. But we are going to fix this later, right? So string contained. But the thing is, what we'll probably do is I'll probably make shared sources into an object file, like a single. It compiles it into a single file. So let's see. Did I just make a mistake? I feel like I made a mistake. Last string contained. No, it's fine. Okay. And then JKLR. That's correct. util.c commands. C. And then rank coverage goes here. Free kanji keys goes here. And make map. Oh, I made a mistake. This K goes before L. Even though I double checked that, I just kept on making the mistake again and again. Kanji distribution and mapping. No, here. Okay. Now I'm checking the order. That looks correct. Now, do the same with headers, I suppose. Okay. Sources, shared sources, headers, okay. Now save that. Fix up of H2. Get rebase I. Okay, we have conflict, as I figured. So resolve all conflicts manually. So where are we right now? We are right here. We're about to add in. Yeah, we're about to. So I essentially just need to combine these things. So headers is, let's see, how is headers different between these two? Kanji distribution commands. Kanji DB, kanji distribution mapping, domaji.h, rank coverage, util.h. Okay, I see all of the headers down here. So this is saying that, okay, I want to be careful here because I have a feeling I'm going to make a mistake. Parent of fix up. So this is, I guess, the common ancestor. I want to be very careful here. Move map generation to a separate shareable module. Oh, the reason it's like this is because I added a keyboard module here. So keyboard does not need to go here yet. Keyboard should not be here yet. That's why. Yeah, this stuff can be really tricky if you're not careful. And I guess I'll just do this like I have with sources. Okay. Now git rebase, continue. Move map generation. Shareable module. Okay. This does not have keyboard in it yet, which is good. Alright, now we're adding the keyboard module. So let's get rid of this. Let's just get rid of all these things because we're just going to add it manually now. keyboard.h and keyboard.c. Okay. Then git rebase continue. All right, good. So I'm going to go ahead and run these commits through our tests and make sure that they all pass still. And O2 make KO or pending and make keyboard.c. Okay. Keyboard.c. Why is that a problem? Oh, is that because keyboard.c does not exist yet? Yes, that's why. Keyboard.h. All right, now we can make. That all works. Good. All right. All right. Keyboard.c. Keyboard.h. Okay. So here's our C file. Now, I want the keyboard to look a lot like this, except I don't want there to be so much room between the keys. I want this keyboard to appear smaller. So I basically want these two lines to kind of be merged together so that there's only one single border line in between the keys. I still want this spacing between the two hands, and I want a number row here because we're going to be using the numbers much more actively than in this old system. We're going to use the number row much more thoroughly in this new system, so we need the numbers up there, the number key guide. And other than that, it's basically the same. So we have equal sign here. So we're going to need to get the line drawing characters straight. We need line drawing characters. And I am wondering if I want to do full width line drawing characters or half width line drawing characters. If it's full width, then it's going to be the same as the kanji. But I think that we can just get away with doing like single width, right? I don't really see a reason to use full width. So let's go ahead and do it that way. All right. So I think we're gonna have just the keyboard be a global function, a global variable, static char keyboard keyboard, and this is going to be like this. Now it's going to have, how many lines is it going to have? So we have the number line, right? This is the first row of the number line. So it's like, let's get some line drawing characters. We'll get this. Let me grab this one. Right. And then we need this. Okay. Now we need a down-facing T-shaped line drawing character. So let's look in Unicode, like Unicode line drawing code points. I think I searched for this a long time ago. It's still in my history. Box drawing character. All right. So down-facing T is this. All right. Good. Now, this is the line. This is the very first line of the keyboard. I'll put a \n there because we're going to have that for now. Then we have a this. We have a vertical pipe right here and here. and this is the number row. So number row, and here now we have a lower left corner. And now, by the way, this is where we're going to put the character, but there's a kind of a catch. This is currently two bytes, but the kanji characters are usually 3 bytes long. I think they're all going to be 3 bytes long. At least for now, they're all 3 bytes long. So I think this is enough. If I end up being wrong, then we're going to pad this with null bytes. But for now, let's just kind of ignore that problem. Let's kick the can down the road. We don't really have to worry about that right now exactly. So now we need another lower facing T here, right? And here, oops. So yeah, I'm gonna put this here. All right, and and then we need an up facing T character. Up facing T. Okay, number row, and then we have. Let's put this at the end of the line. Oh, we don't need these. Okay. We're going to make it all a single string. Static char keyboard. All right. So yeah, this is currently 2 spaces. So we want to replace that with a single double width space. Let's make sure that's 3 bytes long. The full width space. There. Printf that. Let's see. That's 3 bytes. Okay, good. Now, what are we going to do next? We're going to do the. Let's put this here. Number row. All right. That goes there. And this is the query row. Right. So let's replace this with a full width space. Right. Oh, and here we're going to put stuff in the shift area too. So this also needs to be full width right here because we're going to replace this with a kanji in some cases, because if you have a shifted character or a shifted key, that's where the code will be displayed. As an example here, we have the shift to the right. We put it to the right of the character. But I think what we really want is we want to put it up here for this new system, because there's not going to be that much room in between the keys as there is in this old system. And the reason why I'm trying to minimize the size of the keyboard is because I want to be able to zoom in really, really far and see really, really close and see the kanji in the greatest with the greatest size possible. And if this takes up too much of the screen, this keyboard, then that limits how close you can zoom in. All right, so there must be a full width version of these characters. Full width, double characters. Is this one? DOS, code page 437. Historical, list of Unicode characters. Box drawing, Unicode block. Block elements. Geometric shapes, list of Unicode characters. I'm not seeing anything here. Maybe I just want to do this. Yeah, that doesn't look very good. That is I'm pretty sure that's 3 bytes large, but it doesn't look good at all. Full width, Unicode line drawing. Oops. Line drawing, full width. table, box drawing, block elements. These four arms can be slid separately. The absent plane are heavy. Each of the four arms. It has two numbers here. I wonder why there are two numbers. That's interesting. Using a gray background to show how the figure meets the cell boundary. In the actual display, each pixel is either fully on or fully off. Details clear. The gist below are considerably larger. That's a GIF file. Unicode number and hex. That's because one is hex, one is decimal. It's rendering according to the font employed by the user's browser. Okay. Well, let's actually get this straight. How big are these box drawing characters? Maybe they are actually 3 bytes large. Let's see. Let's just print one. Print F. Oh, this is 3 bytes as well. So actually, this works fine, at least for now. Later on, we're going to have to pad this with more null bytes so that we can print Unicode characters that have Unicode kanji characters that in UTF-8 take up more than 3 bytes. But for now, we're just going to assume that everything takes up 3 bytes. Okay. Now, but the thing is, this is 2 characters that are 3 bytes large. So if we replace one of them with Unicode, we're going to have to pad the rest with 0 bytes. Because this right now, these 2 pipes are 6 bytes total. If we put a kanji up there, that means we're going to have to pad it with 3 null bytes afterwards. Maybe there's like a way to use line drawing characters down here that are not, that's just like empty. No, there's no like empty. Oh, maybe, yeah, there's a space, but that's only going to be 1 byte large. Okay. QWERTY row. Then now we have this. Oops. Okay. And we have this. Don't need the semicolon. And this is the ASDF row. ASDF row. All right. Okay. And then we have yank to A. And then we have the final row. And this is ZXCV row. All right. Okay. 2 of them. All right, so this is the general outline of what we want. And the hard part, I think, is just finishing drawing this. I'm going to think about how I want to do that, and while I think, I'm going to pause the video. Okay, I think we are ready now to finish this this keyboard drawing here. So yes, let me try a few things. I'm going to paste this. Okay, good, that's working. So I need 10 keys here. I'm going to do 4, 5, 6, 7, 8, 9, 10. The last one needs to be a upper right corner. And where is that? It is right. Why am I not seeing it. It ought to be in this row, I guess, but these are double. I guess these are double width ones, so I want over here. Here. There we go. Okay. Now, perhaps we can do this. Okay. All right, good. Now here we need a single width line and then another one and then a T-shaped here thing under upside down T shape. Here. And over here we need another upside down T shape actually. And here we need a upper right thing. Okay. And the next row is kind of going to be a repeat of what we just did. Ah, okay. So here's something tricky. We need to have a T-shape connection here. Right there. Okay, good. Now I guess we can copy this. Right. Good. Then we got to do this one. See how is this good. And here we start with this and we finish just like we did the upper row. And now copy this row. And then we take this. Oh, but this one's different. This one doesn't have any connections on the bottom. Let's anyway use this. This row is the bottom, so it looks different from the others. That's okay. All right, let's fix the lower right corner. There we go. And now we can, let's see here, how do we want to do this? So I can paste and then delete. Okay. I guess if I can do a search and replace here for this character and replace it with a dash horizontal line. Oh, but it did it on the other lines as well. Oh no, it didn't. Good. Great. So after some thought, I think I want to keep this keyboard as a constant, this string as a constant, and that will let me fix the keyboard that we allocate later. So we'll call this maybe keyboard static car keyboard size of keyboard, right? Right. Excuse me. So this, I'm not sure how to initialize this so that it's the same as the keyboard above. So as long as we finish this line drawing here, let's close this page. We don't need this anymore. And we'll also let me save this and go back to the main window. .c. All right. So for this, I think what I'll do is I'll initialize it initialize it here. If keyboard, not keyboard. Okay. And then, so we might have to move that code around, but that's just what it's going to look like, at least, even though it may not be in the right spot at this point. Now, excuse me. So let's go ahead and finish this function. Import.h. And what we can do is we can do something like so to size t key index for key index. By the way, maybe we should do something like this. Could we make a type def for the key index type? Key index, something like this. Type def key index. And this is of type uint8. Key index to chart map. Okay, key index type. Key index type. Excuse me, ki, k is less than mappable char count, ki plus plus. Now for this we need romaji.h. Okay. Now, if now we need to basically we need to figure out where in the keyboard we're actually going to write this to. Now, I think that to make the math easier, we're going to make all the rows be the same length. Okay. All right. There. Now, this still is not that easy to figure out. It's still a little strange because the amount of space that this row takes up in memory is going to be different from this one. So, and if I look at this, it looks like even like this row and this row will not be the same amount of take the same amount of bytes, because up here we have a regular space, and down here we don't have a space. We have a 3-byte character. So this is 3 bytes, and this is 2 bytes, or 1 byte rather. And so that's going to make things a little bit complex, I think. So maybe we can kind of hack the spaces here so that every line takes the same number of bytes. We can hack the spaces of like the that we have until the new line and see how that works. So for instance, this is probably going to be the very longest line down here, but let's use this as an example. Let's see how long we need. Printf this and count. This is 98 bytes. All right, this one right here. Now we could say we want each line to be exactly 98. Let's say what is this? Printf That's also 98. Oh, did I just copy the same text? How did that happen? Let's do this again. Copy. All right, there we go. That's also 98. Okay, and maybe this line, let's see what this is. Printf. That is only 66. So is my hypothesis right that this line is less than the next line, or rather two lines below it? That's 96, and this is probably going to be 98. 98, yeah, okay. So we could add two spaces here, and then make that be equal, but I'm not so sure if I like that. So even if we add the backslash n here, it's not going to make the math any, I mean, even if we add extra space, it's not going to make the math any easier. Oh, one thing because this is a lot of characters to pad, we could pad it with null bytes, because we're not going to be using f put s, we're going to be using something that writes binary, so it's not going to mine null bytes, and that would be and so that means we could just pad as many null bytes as we feel is necessary. And that's excuse me. Or we can have a kind of array here, which tells us what is the like line offset for each line. So the nice thing about that, though, is that we can just have the shift characters be like later, the shift line. So the first line would be this, the next line would be this, and then once we do all four of those lines, then we tell what the offset of this line is here. Right? That would kind of make things a little bit nicer, I suppose, in code. So maybe we should just do that. So we have this. Let's see if we can figure out. So this was 96, and then we have a new line here. That's 97. And down here we have 3 bytes, so that should be 100 to get here. Right, that's a 100. Now, what would be the easiest way to kind of get this to calculate the rest? Because this could get tricky. Oops. Maybe we can do something like, all right, I want to get into, we can copy this, all right, temp/keyboard, and paste it, and delete these, and delete that. All right. Good. Now we just kind of have the keyboard string as it is in memory, just in this text file now, and now we can maybe do a hex dump of temp keyboard, and that's kind of hard to read. Let's zoom out a little just for now. Oh, that's really hard to read. So, but we can probably figure it out with the new line, like the new lines, which is 0A. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9 new lines, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9 lines here. So the difference between this string and this file is simply that this file has an extra trailing new line. So we could say that this is now what is 100 in hex? That would be %x 64. Okay, so yeah, right here is what we gave around, let's see, 80, 80, and So what we want to do is we want to have two spaces, right? All this, we want to, after the new line, we have some spaces. Wait, do we? 0A, E294. Those aren't spaces. Oh, because this is 80, 80. 80 is not a space. I'm confused. 80 is 80 is the double width space. 80, 80 here. I guess it's in, but that must be in UTF-8. Oh, this is UTF-8, so it's a little bit confusing. But uh, but the single byte characters are the same. Now we do have like 20 for regular spaces, don't we? 20. Yes, we do. That's what we expect. Okay. So let's do these line offsets in hex because that will be easier. Right. And we have a 0A, 0A. So after this is the first line, then this is the. So by the way, let's see how many lines. So we have 6 lines. 1, 2, 3, 4, 5, 6, 7, 8, 9. No, we have 9. And we basically use all of them except this last one, right? So we have 8. I mean, the ones that we fill with characters are going to be all of them except for this last one here. And by the way, I do intend to change this so that we have so that these are like a different character. I forgot to do that. Let's do that some other time. I want to make it clear that like these are these are like where you separate the two hands from each other, which means that there's going to be like a thicker line down the middle here. Now, okay, so we don't need this 0A. This 0A is for the next line. Okay, so the first line, excuse me. So here we'll add the 2 lines in parallel, the 2 pairs of lines. Down below this will be the shifted line, and this will be the original line. So for the first line, we basically want to skip this and put it right here. So I think that just means it's going to be 3. All right. Now, after we do 0A, then we do the first non-shift line. Then 0A, this will be the second shifted line. So this is 9D, 9E, I guess, or no, 9D, and this is E and F. So 9D is a new line. And then we have, so let's see, this is what first line in this area. This is, and that's shifted. This is second line. And this is the third line, and that's shifted. So here we essentially have the same thing as the last one, but we add 6 instead of 3 because there's no spaces at the start. So E294, second line starts with E294, and third line starts with E294. Well, because the last byte is what distinguishes the actual character. Okay. Oh, first line, second line, and third line. That's third line is what we're doing now, and this is A. Let's see, skip it. We're gonna skip, I guess, 2 characters, so 6, because we want to put the guide here. So this will be E29. This is 1, 2, 3, and skip 1, 2, 3, 1, 2, 3, and here. So this, I believe, is where we want to put it. So this is A4. A4. Oh no, it's down here. So by A4. Okay. Good. Let's change this so that we can actually annotate it. let's put this into a different file. Temp slash keyboard hex. All right. And here we're going to open keyboard hex. Okay. And then we do 0A. Okay. So we did the we did A4, which is right here. Now we got to do the second non-shifted line, non-shifted row. And this is, we're going to skip one space and then one this thing. So that's 4 bytes, it looks like. Okay, so this F0, we're going to skip 1, 2, 3, 4, and then we're in E3. E3, I guess, is the... let's make sure this actually makes sense. E3 8080, is that the full width space? Let's check. E3 80 80, and then X. Let's put an X so that we can see what's doing. Yeah, that's correct. Okay. So 80 80, and that's where we actually want to be. We're going to put it in that spot. So it is 100, so it's 103. That's where this starts. This character starts. 103. Okay. And then after we've done 103, now we got to do the next row, which is a shift row, and this is 1, 2. That's this one. So we want to, after the new line, we want to skip 1 byte, and then this and this. That should be 7 bytes total after the new line. Okay. So 147 looks like. 147. Yeah. Okay. Okay. And the next line after 147, it's down here. This will be a non-shifted line, and we basically want to go to the first like hold on a second. We want to go to the double width space, which is right here. And so that would make it 1A. This is, at this point, it's 1A8, so 1A7. Okay. By 1A7. Okay. Next is a shifted line. So this is down 1A, 1E. So this is the last one. And that means, and this, for this one, skip 1, 2 bytes. Then that's 3 more, 5 and 8 bytes to get to the one we want to overwrite, 8. So after here, we do 1, 2, 3, 4, 5, 6, 7, 8. Oh wait, this doesn't look right. Why is there a double with space here? 1A. Oh, I'm looking at the wrong line. So we skip 8, 4, and 8. That means we put it right here. Okay, this would be 1E, and then 12, which is C. 1EC, D, E, F. Yeah, 1EC. Okay, and we're finally done with this these shifted lines. Now the next one, the last one. Let's see here. We got his page down. Okay. 2, 4. Now for this one, we just find the first double with space, and that's all we have to do. That's easier. Um, and this is 2, 4, and then so we want to put it at this one. 2, 4, F, E, D, 2, 4, D. Okay. 2, 4, D. 2, 4, D. Okay. Let's change this to a UN16 type. Okay, good. So, I'll just increase my volume because of. Okay, I really screwed up. I just lost a whole bunch of recording because of I just turned off the microphone. I didn't understand how this button works on my microphone headset, but apparently when you push it, it completely mutes everything that you say. So that means that all of my explanation is kind of gone for the past 30 minutes or so, 35 minutes. So that's unfortunate. But this is what I did. I found out where every single line starts using a hex editor to kind of make sure I knew what I was doing. Every single line, what their byte offset is here. Okay, and I created a keyboard here to store the like keyboard as it's written. Now we update it. The idea is that we this is like the scratch space, this keyboard here, and we write to it as we basically just write to it whenever we're about to draw it. We write to it using to allowing it to store the keys the keys that the user could type and what characters correspond to each key. All right, so if the first byte is 0, that means that we haven't initialized it yet, and so we basically initialize it here, and then we loop through every possible kanji character index here, and including the shifted key indexes, and then we populate it. We get the char offset based on first where the line is. The line will give you like where the very first character is supposed to start, and then we increment the character offset based on the index in that particular line we want, and there the stride between each character is longer in these lines here, in the shifted lines, and so we need to decide based on which line we're in. Yeah, now that I think about it, maybe we can make this even simpler. So we'll do 3, 6. Nah, I guess it's fine as it is. And then we do after we do that, we also store the number of bytes that the new character is allowed to consume, and we pad that with null bytes here. And this string is not null terminated. This is going to be sent right to the system. It's going to be written as binary data, essentially. And terminal emulators, apparently, as far as I can tell, will just treat null bytes as like a no op. And so that's fine. We just kind of, if there's extra bytes here, then we just kind of forget it. We just put no op bytes after it, which are null bytes. And but for the character itself, we copy it from the mapping and put that wherever the char offset is. Char offset is used to index into keyboard P here. Okay, and then we do a draw. We take a file stream here, And later on, I'm going to add another draw function. Oh, this actually needs to be draw file, I think. Keyboard.h, keyboard draw file. Yep, okay. And I'm going to, now the thing is, this is really only for testing. Then I'm going to add another one which writes to a file descriptor. The reason being because if you use a system call and write to a file descriptor, it's not buffered. And that's essentially what we want because we have our own buffer here. There's no need to use a buffer. And so the idea is that we want to make this as kind of fast and snappy as possible since it's going to be writing to the screen as fast as the user can type, and we want to avoid flickering and delays as much as possible. And so I believe that the system call would be would be better here. So we can maybe even just call this draw for test, but I don't know if I like that naming convention. So we'll just name it in a descriptive manner. And so I created this test file, and we mapping.h. So now we want to actually populate our mapping. Mapping equals this, right? All right. Mapping, and then we do mapping destroy, mapping here. Okay. And we'll do mapping.ergonomic sort equals 1 because there's not really any other way you'd want to do that. But yeah, do we really want to test the ergonomic sort? I guess we don't. But the thing is, I do want to see how well it works. So let's do mapping populate. So we will do the ergonomic sort because I want to get a better idea for what we're actually going to show the user. Mapping keyboard update mapping, and then the prefix is this. Then we do keyboard draw file. It is out. Okay. Now we can try this. Mapping. We don't have mapping. Okay. Pound if, not def. Mapping h. Is that how we call it? What do we do? Romaji.h. Yes. Okay. Define. Okay. Up to mapping. Test. Struct mapping. Okay. I didn't declare this variable properly. Let's call it just m. Okay. Okay. Well, that should not have passed. Draw file. Right. Keyboard stream. Draw file. Not F right. That is surprising. It looks like it didn't actually run it. So let's go to Makefile. Let's find keyboard test. Keyboard test. Oh, I didn't run it. There we go. Oops. Okay. Okay. Now, so we can actually cat this. Okay. This doesn't look that bad. So this is correct. The A and then shifted is A. But for some reason these are supposed to be shifted. Okay. Yeah, this is actually correct. Our first try. So this is very nice. We basically have succeeded in the first at least in the default view of the keyboard. So let's try this again with like a first key typed there. And let's say we type a slash, all right? And so what comes? Okay, cat. Okay, this is almost correct. So this means that if we type a slash and then we type slash f, we'll type this character here, which is good. But I do want to fix something here, I guess. I kind of want to make this a a what you call like a separator for the hands. 1, 2, 3, 4, 5. So on the left hand, I want to include the 6. 6, 7, 8, 9, 0. Okay. So 1, 2, 3, 4, 5, 6. So we'll add a let's add a double width character here. Unicode line drawing code points. Okay. Okay. So, and this should make it a lot easier to read. Right. Actually, no. 1, 2, 3, 4, 5. Oh no, we want to add it a little bit later. There. And then we do it here. Okay. And okay. So we want an upside down T where the right side, where the line on the right side is not double width. And I don't know, that should be here. Or it's not, rather it's not a double line. Upside down T is, so we have this. I basically want this, but I don't want the double line on the right side. I don't see it here. So maybe this is not something that we are supposed to have. That would be unfortunate. But we have it here, right? We kind of have that here. But I guess that we don't have it otherwise. Oh, wait, do we have it here maybe? No. What are these? Set of line drawing characters as well. Okay. So yeah, this is a bit unfortunate. I was expecting there to have this kind of support. I guess we can just kind of approximate it. It's not going to look great, but it will still look not that bad either. So where's the upside down T here? Still having a hard time believing it's not there. Oops. Didn't work. Copy. Oops. Okay. So paste it, delete that. And get. All right. So now we want the upper part of the T. We can do this one. Okay. That's good. That looks better. And then a horizontal line. That's double width. Oh, look, we have this. But I guess we can't really use that. Where's the horizontal line? Here. Upside down T. So they do have this thingy. That looks better. Maybe I'll just use that. And then this. Okay, that looks pretty good. I'm actually pretty happy with that. And a this. All right. Okay, now a right side up T. Okay, good. Let's try the test again. Default view. Let's make sure that looks right. Okay, good. So now let's run it again. Copy this. Let's update the test. Oops. At cat. Okay. All right, now this is just a bit of a mystery. Why is this not looking right? It looks like we just didn't have the right uh, line offset for this one. Perhaps that's the problem. We just need to maybe move it back by 3 characters and it'll look right. Make. Okay. Let's copy. Let's show this. Oh no, this is the. That didn't work. It's actually the first line that was wrong. So let's change this to 1. Let's try that. Okay. Okay, I think that worked. First key typed. Let's try this. Okay, good. Good, this looks very nice. So yes, that was our goal for this time, this session. And yeah, I think I'm very happy with the way things went, except for the fact that I lost a bunch of I lost a whole bunch of talking content. But for now, that's good. I suspect that there may be a problem with kanji that take up more than 3 bytes. I kind of think that there are kanji around that do take up more than 3 bytes, and I mean there definitely are. It's just that I think that there already may be some in the database, and so kanji DB there is a like a common character. Let's see, its radical is mouth. So let's see, we can go down here. Let's see if we have it. There's actually like a common character in Japanese that was added as a later extension due to a kind of error, an oversight. And this one has 2 residual strokes. And if they have the variance of it, then it's fine. Okay, here. Okay, but this has a rank of 2000, so it's not going to be very common. So it's not going to show up in our keyboard rendering yet because it has a rank way above 1250. But if we do this, let's see, printf. So we'll say, oh, this is 3 bytes. I guess I can't really tell that if that's the variant or not. So there's like this character is funny because there is a variant which is actually a different character, but everyone just thought it was a variant, and so it's a totally different character, and the totally different character which people should not have been using was put in the original Unicode, but the correct character was added later. Apparently, this is the original one that was added because it's only 3 bytes, and so yeah, that's how that is. And I'm surprised that the correct one is not in this list. We may just want to replace this with the correct one, but but that's for another time, I guess. So let's review what we did today. We added a new test case here, obviously, to handle checking the keyboard. We created this keyboard rendering logic, which is highly optimized for, and we're going to eventually use the system call to write it. And we created the new keyboard module here to do that. We created a simple test for the keyboard module. We moved this comparator function to make it public, and yeah, that's why that header file is changed. And so I think that that's all that we want to do. Oh, you know what? Let's commit it. Let's commit it and fix that Makefile as kind of a bonus uh, piece of a bonus task. So we commit this. We'll call it add keyboard. Or no, this is actually an amendment. So HGA to edit. Okay, good. Now we can fix the Makefile finally. So shared sources. Let's just say this is, we'll call this shared.o, right? And this requires all of these files here. Okay. Now we are going to compile this with CC and call it, right? So we are going to output that file, and the input is all of the sources. So how do we refer to the sources? Makefile automatic variables. I've got to look this up. I've been meaning to just sit down and read a bunch of Makefile documentation and just get it really really flat and down pat. Target member name, and target is an archive member. Name of the first prerequisite. Oh, this actually might be helpful. I might be able to use that. Name of the first. Well, let's just fix this for now. May not have a chance to fix the other stuff. Names of all prerequisites that are newer than the target. Names of all the prerequisites with spaces between them. I guess that's what we want. Okay. But the thing is, this is not going to include header files. So maybe we do want to have that variable, shared sources, and then shared.o, shared sources, and headers. Headers. Where's headers? Headers. Okay. All right. So we'll do a cc-o shared o and shared sources. All right. And then we put shared.o here, shared.o here, and we don't actually need all of, so we don't, maybe we don't need this main.c and .c. Okay. New sort. Okay. Test sources. Yeah, I don't think we want this sources thing anymore. Okay, let's see. Test sources. All right. Delete, change to T. We'll call it shared.o and testutil.c. Headers. Okay. Maybe we do want sources. We'll do sources equals shared.o and main.c. Sources. Okay, there's probably like a more idiomatic way to do what I'm doing. since I'm just really cobbling stuff together. Undefined reference to main. New sort sources main.c. Make. CC. Okay, what is the command line we're running here? Oh, so we need to, the way we do it is, I guess we need to do -c. How do we tell it not to link? So I think it's just C. C. Shared.o. Oh, -c, I guess. Oh, shared.o. Okay, so basically we want to intersperse -c for all the shared sources. Name all the prerequisites and space between them. Name doesn't contain the prerequisites. Visit rule matches. I don't see anything about interspersing. I could just use printf, maybe, which seems quite wrong, but we'll get into like printf actually %o %s rather, and then shared sources. Okay, let's try that. No input files. Maybe we need to escape it since we're not using. Okay. Escape. All right, Makefile. Maybe we do a literal. How do we make a literal $? Echo $, I guess. That seems to be what this is suggesting. So Makefile need to escape the extra $ doublet. Okay, I guess that's what I got to do. Input file. Legal option -c. Printf. Okay, almost there. Cannot specify -c -s -e with multiple files. Oh, really? Okay. So this is more complicated than I thought. Let me pause the video and figure out the right way to do this. Okay, I think that I know what we need to do. We can use implicit rules to automatically build the individual .o files into C files. And so what we do, this this will automatically be used by Makefile, by GNU Make rather, to make any .o file which does not exist yet. And so I think what we need to do here is we have so that actually doesn't make sense now, because that means we have to write all these shared sources, but we also have to write .o. Then we have to write the list of .o files in order to go with them. That seems like a bit of a bummer. So maybe we could do something like this. Maybe we can do shared.a. Yeah, I'm already changing my plan. Shared.o. So this is now a, and a shared.a. So this, let's see, shared sources. So it can do for source in shared sources, do, and do cc, and done. Source. Yes, and then we just actually call this -c compile, and then we want to go ahead and link it. So I believe that we just do, let's see how AR works. Create, modify, extract from archives. So archive and then member. It's just shared .a, and oh, then we don't, but then we still need the .o list of .o files for AR. Okay, I think I actually don't know what the right way to do this is, because I just don't feel right repeating myself for the .c files and the .o files. It seems like I must be missing something kind of obvious, because we need the C files to specify the dependencies. Oh, I guess we don't need the C files to specify dependencies because, okay, all right, now I think I know what we need to do. Shared, we don't need this. So we do need shared sources. So we do need this as O files. Okay. Shared sources, and then so here we do shared sources. Okay. And let's see what we've changed so far, because it seems like Make is basically smart enough to turn these O into these C files into O files. We just have to specify them as dependencies. So test sources equals shared sources. So undo this change in test sources. Shared sources. Okay. Okay. Now CC, now it's not CC flags, it's actually just C flags is the right way to do this apparently. Otherwise, this implicit rule will not catch it. So C flags, and I guess we don't need to. We don't really need to. So maybe we don't really need this. We just need C flags. Oopsie. I kept caps lock on too long. CC equals. Let's just keep it as it is, and we'll call this C flags. C. Yeah. So that is CC, and the thing is, if the user specifies C flags, it's going to be included in the implicit flags, but it's not going to be included in our flags. When we use we basically need to do the same thing as the implicit rules if we want some consistency. So let's do this. C flags equals this, and now we need to add the C flags here. Dash C flags. Okay. C flags. And maybe this can just be changed to .o here, because apparently it will knows how to create the .o files, from the C files by itself. Okay, test sources. So it actually seems like anytime we use a .c, we can actually replace it with .o, if I understand the documentation right. So here, test headers, test sources. Change this, find C. Okay. Now, what happens if I make? Wow, it actually worked. It's amazing. So we also want to delete star.o, I guess, if we clean. Now, if we make clean, let's see. Okay. All right, good. Make. And that was pretty fast too. It looks like it really did exactly what we wanted. And so we set C flags. Now what if we try and change C flags? I wonder how that's going to work. C flags, make clean, and make C flags equals -G. I'm guessing it's going to override what we just did. Yeah, so fortunately this thing overrode what we tried to set in the file. I don't know if that's exactly what we want. Maybe that's what we want. I'm not sure. Let's put these on different lines. Oops. Okay. Good. All right. So that's great. So now we can commit this and say that we have just standardized Makefile. And I'll write a better commit message later. So anyway, that's the end of this video. So thank you for watching. Okay, I had a little bit of a change of heart in something that I did, and so I'm going to go ahead and fix that right away. In keyboard.h or keyboard.c rather, we kind of hide this variable which has the keyboard buffer, and then we create a test only function which writes it to the screen. It's only test because it uses this buffered C library, and I think that I don't really like that very much. I mean, the idea of exposing a variable just as it is really does not bother me that much, but the idea of like test only code in the production code bothers me more than that. And so I'm going to have this extern char keyboard here. Okay. And so this is let's call this, let's make this a pointer here, and then we can do size t keyboard size, right? So that the user can know how much they need to write. And we'll do char keyboard equals 0. And yes, on second thought, let's here. We'll have an accessor which returns the keyboard. So it would be like char const keyboard bytes, okay, and size t keyboard size, right? So we don't need the stupid draw thing. Okay, now keyboard. Let's go ahead and keep this as it is. It's static, and have these two. We need these functions so that the user knows how big it is. Return size of keyboard. All right, and here we say return keyboard. Okay, and now here this can actually really just be a test, provably only test code, because it's actually in the test file. Draw file. Okay, static keyboard draw. Now, because it's not in the module, we don't prefix it. Let's just continue to, yeah, I don't know. So the thing is, it's not in a, if it's not in the module, I don't know what the naming convention ought to be. I guess it should just be verb noun if it's not actually in the module, but noun verb if it is in the module that the name corresponds to. Draw keyboard, and we do word out. Okay. Now we just do this. Draw keyboard. Okay. There. Stir. Declares function stir. Okay. So now we can do this. Oh, I forgot to actually call exit here. Okay. So let's get a random number. $72. Now we're done. Okay, draw keyboard, and we have to do include arrow.h. Okay. Good. And so we can go to keyboard.h, and now we don't need the standard standard io.h anymore. Make xf printf. Keyboard undeclared, first use in this function. Did you mean draw keyboard? Here, keyboard bytes and keyboard size. Okay, p error. No.h. Why is that not working? xf printf. I didn't include util. And then standard lib, I guess. Why is string error not working? I thought that would be in. Oh, that's in string.h, isn't it? String.h. Okay. Okay. Now this is going to be a fix-up of the previous commit. So we will do a GCM fix-up equals h2 get rebase -I h5. Okay. Now, as I was typing all that code out, I realized that this may not work anymore. So we have new sort depending on headers, but really it doesn't depend on headers. It depends on headers, but now the sources, the sources, which are these .o files, these now depend on the header files, and so it's we need to override the implicit rule somehow to indicate that these depend on the header files. And let me let's see, how do we do that? So GNU make implicit rules. So you need to like add dependencies, right? Dependencies. Variable B. Depends on the files, and the file scanner depends on the file parsetab.h. Two targets. Okay. Automatic variables. How patterns match anything pattern rules, canceling implicit rules, defining last resort default rules, defining pattern with the same target purpose commands. Okay, so I was trying to figure out how to actually define, how to actually make the header files cause a recompilation of the sources, and the best way I can figure of that is to take whatever the implicit rule is to compile C programs and redefine it, but add the header files to the dependencies. And this means that any change in the header file is going to change the sources that must be built, but that's good enough, I think. So for now, So we'll just do this, and we'll say headers, and so it's okay to have test headers, not put test headers in an implicit rule, because test headers are used, because we don't use implicit rules to build the tests, it seems. Oh no, actually, kind of we do. We do this. So, um, okay. So we don't need headers here, right? Because we're not compiling, we're just linking. So what we'll do is we'll just add, we'll forget the test headers thing, and we will just add the test headers to the normal headers. Test util, okay. Test sources, shared sources, okay. Now headers. So headers are used for compiling, and so basically what we're going to do is we're going to just use whatever the implicit rule is usually going to do. And we don't need CPP flags. Oh, that's a CP processor flags. Okay, I guess we'll keep those. And yeah, this is I guess fine. So we don't need test headers here. So test headers. Test headers. Okay. Now we also don't need to repeat the sources down here. There was a way, I think it was with $A. So let's look for the where's the all dependencies thing, or names of all the prerequisites that are names of all the prerequisites of the space between them. So it's $caret. Only the name member is used. $caret. Okay. So we do $caret. Keyboard test. Okay. And $caret. Yes. Okay. That looks good. Now we can probably make this into an like some kind of a generic rule. So now that I've read a whole lot about Makefiles, mostly when I wasn't recording, so let's see how this works first. Let's do your test bin test. Okay. No input files. Oh, here. We have to add this. No, star %.c, I think. Oh no, there was something about let's try this. See how this works. No, we need to do the name of the first prerequisite. Okay, dollar less than. Okay. Very good. So now I think we can actually even do better. Let's say this is star test, and this relies on tilde percent test, and then the list of prerequisites here. Okay. I don't think we need these other ones. Map test. Okay. Shared sources. Let's try that. Make clean and make. Oh wow. Okay, this is much nicer than what we had before. Free kanji keys. So what is it doing here? Free kanji keys.c, and so this is where it's building the object files. And down here where the command line is longer, what is it doing? It's building, it's linking all the .o files to make the test binaries. Okay. So instead of shared sources, I think the better name would be shared obj. Okay. Sources. Shared obj. Oops. Obj. Okay. Test sources. Now instead of sources, we'll just do. Now, do we have to actually put this in a variable? No, we don't. We can use that thing, shared sources, shared objects. Okay. And I think that we need to do what was it? Dollar at, or for all the prerequisites. Oh, dollar caret. Okay. Good. Test sources. Still, we don't really need this anymore. Okay, we only use it once. Okay, this is looking a whole lot cleaner. Very good. Test and new sort. So C flags, shared objects, headers. Okay, so to build any .o file, we depend on all the headers at once, and so then we build using the .c file. We compiled that, and now that should almost match the implicit rule, except for headers is added here. And then new sort, the binary itself, it uses the shared objects and main.o, and main.o will be built by this, and we compile everything together with this. For the test files, test binaries, we build test.o, shared objects. We depend on test.o, the shared objects, and testutil.o. And that's fine. Okay, this looks pretty good. Make clean. Now make. Okay, good. .git. Now, .o is already in the .git ignore, even though I don't think I was using them before. Okay, so this is now a much more attractive Makefile. Test. Yes, okay. Maybe just call this test all. Nah, just test is fine. It's nice to be able to just say make test. Make test. What does .phony mean? I think it means that there's no output generated because of it. Make test. Good. Okay. Now, we can commit this. This is part of standardized Makefile. We'll amend it. And so to summarize, yeah, we really made the Makefile a whole lot cleaner. I just had to read up for like a few minutes about how Makefiles work. And so that was definitely worth it to clean that up. So anyway, now I can't think of any reason to continue the video for real this time. Oh, this is a little annoying. I don't think I like being inconsistent here. Let's just do that. Oh, but we do it here. Okay, so sometimes we put nothing on the first line. Sometimes we put something on the first line. So let's just be consistent and always put nothing on the first line. Okay. I mean, in the case that we have multiple lines of stuff. Okay, headers, test, yes. Okay. Now make clean and make. Okay. Commit. And okay, so there. Now we are all done. So thank you for watching.